A very good day to Dr. Go and my fellow friends. In today's video, I'll be showing you how to grow your very own sodium chloride crystals at home. First thing first, let me tell you the things that you are going to be using to grow your own crystals. You are going to need a cup of warm water, a pair of scissors, thread, a toothpick, an empty container, and some table salts. Once you have this prepared, you are ready to begin growing your crystals. Now, I am going to show you how I grew my own sodium chloride crystals. First, use a pair of scissors to cut off a string of thread in a desired length. Next, tie the string of thread to a toothpick. After that, pour warm water into an empty container until it fills about half of the container. Then pour some salt into the container containing warm water. Start stirring the solution to dissolve the salt. The steps of pouring and stirring salt solution in the container are repeated several times. This is to dissolve as much salt as possible in the solution. Stop adding any more salt into the solution once the solution becomes saturated, where no more salt can be dissolved. Finally, put the toothpick on top of the container with the string of thread is dipped into the salt solution. All that is left is to leave the solution for several days for the sodium chloride crystals to grow. The solution needs to be checked regularly to examine the progress of the crystal growth. So, this is the result after 1 week. As you can see, there is some sort of formation on the surface of water and contamination by dead ends, unfortunately. Then I check on the string. It is showed that some salt crystals have grown clinging on the string of thread, which can be seen highlighted in red circles. By carefully looking at the crystals, you can actually see that their shapes are in cubic, like this one. This is because sodium chloride crystal, NaCl, is a face-centered cubic crystal structure. But how does this happen? Let's find out. When you add salt to water, the crystals dissolve and the salt goes into solution. But you can't dissolve an infinite amount of salt into a fixed volume of water. When as much salt has been dissolved into a solution as possible, the solution is saturated. This saturation point is different at different temperatures. The higher the temperature, the more salt that can be held in the solution. This is why I use warm water. When the salt water begins to cool, there is more salt in solution than is normally possible. The solution is therefore supersaturated with salt. Supersaturation is an unstable state, and the salt molecules will begin to crystallize back into a solid. This begins at a crystallization nucleation site, such as the fuzzy end of the string. Then, when the water evaporates, the solution will become more and more concentrated. As the water molecules disappear, the salt molecules find each other and join back into crystals. Sodium ion, Na+, which is positively charged, is attracted to chlorine ion, Cl-, which is negatively charged. The two then join together to form sodium chloride molecules, NaCl, through ionic bond. The structure of NaCl is formed by repeating the unit cell. As a conclusion, crystals are simply a structure where all the atoms are perfectly arranged on the atomic scale. On the scale that we can see, this turns into a very smooth lines and unique shapes. Crystals grow because salt molecules in the solution meet up and interlock. As they do so, they fit together like puzzle pieces, arranging themselves in a lattice structure, thus creating a crystal nucleus. As more molecules find the nucleus and connect, the nucleus grows larger. NaCl, sodium chloride, is a crystal structure with a face-centered cubic Bravais lattice and two atoms in the basis.